and welcome everyone. Today I'm going to talk about advances in AI that we've seen over the last several years and how they are impacting us. One of the areas that I also want to talk about is not just how these advances help the folks in the general public, but also more specifically the enterprise that's of interest to this audience. To tell you a little bit about myself, I spent the last 10 years at Google, where I helped co-create Tensorflow, which is, of course, used very, very widely as a key tool for helping folks use machine learning and AI. Before that, I've spent a lot of time across various startups, companies like eBay, and have spent a long time in the San Francisco Bay Area building different kinds of companies. At this point, I recently left Google, and I'm looking to really do the kind of things that I'll be talking about today as well in bringing AI to really make a difference in the enterprise. As I talk about advances in AI, it's hard to talk about them without going back to the past, really, in some sense of how we came to this place. All the things that have happened over the last century. AI is not a new thing. It's been around for a very, very long time. And there are different takes on this for a while. So let's just take a look at some of those and see how they are. So TikTok, something that we hear about all the time these days, of course, as an app. This is not what the term came to be known as initially when it started out. The term actually came from this little robot kind of thing. In fact, it wasn't. The robot term didn't exist back then, but back in the days of Wizard of Oz, from the creator of Wizard of Oz, Frank Baum, back in 1907 in one of his books, Ozma of Oz, he created this person or robot-like creature that was basically would run by winding it up, and it could do certain kinds of things, and it was really an assistant, so to speak, for Dorothy. Now, as I said, at that time, we didn't even have the core term robot. In fact, that first came about in 1920s in this play called IUR in Russia. And, we haven't looked back from then. We've had all kinds of science fiction and novels and books and stories about robots, of course. But moving forward a little, how do we think about AI and what does it even mean? In the 1950s, that's where really AI started to take off. And at this time, something we hear about often, the Turing test, as it came to be known later. When Turing wrote a paper in 1950 where he called this the imitation game. And what he compared it to was, let's say you had two people behind a wall, which you couldn't see, and a third person is trying to guess. And those two people, one of them is a man, another is a woman. The man, in this case, equivalent to A here, is trying to imitate whatever B is doing. And the person C's goal is to really understand which one of them is a man and which is a woman. And it doesn't know that. Now, what Turing went on to say was, what if you replace that man with a machine? Would this person C be able to differentiate between the machine and this other human? And that's sort of, he called it the imitation game. Now, of course, we call it the Turing test. That was sort of the core of how we think of AI and, how do we have something? How do we know that something's intelligent enough, really? Of course, this is the 50s. There are lots of different takes on it. In fact, over the last decade, we've seen Alex Garland's take on it in Ex Machina, where he talks about, this person or this robot where we know it's a robot, but it's trying to convince this other person that it has the same intelligence, the same emotions as a real person. And, his take on how that whole thing plays out. So it's really a modern version of the Turing test, if you may. Now, going back to the 50s, though, the term AI itself came in 1956, and this is for this very exciting conference, Dartmouth Conference. In some ways, that's where this all started. And this term was coined by John McCarthy. Him and Marvin Minsky were the two main people trying to put this conference together for the folks. And this really set the direction for AI for the next several decades. And, as we'll look at some of the things that came out of that and some of the developments that happened over the next few years. So in the next decade, in the 60s, one of the exciting things that came out was this very early natural language conversation system called ELIZA. The person who created this, Dr. Weizenbaum, actually thought it was very superficial. But interestingly, lots of people, including people around him, felt it was very, very real. And this could take different kinds of scripts. So it could, be a doctor, like in this case. In fact, this particular script happens to be one of the most famous ones. And we see a retake on that from more recently. Interestingly, again, we see that reference to the, fiction itself, because the name for Eliza came from G.B. Shaw's play Pygmalion. In fact, that was made into My Fair Lady, that was released around the same time in the 60s. And so, that's how we see this particular piece of history that sort of got influenced by the movies as well. Moving ahead, around the same time, we started to see this thing called expert systems. And the idea there really was, what if you could take all the knowledge from all these experts and encode them in some fashion in a knowledge base? And then you have these inference engines, which are basically rules engines with some very limited matching capabilities. Could you really then have any user ask questions of those systems and get the answers that they care about in all kinds of ways? And so that sort of was the key push back then. And there were a couple of systems, the first called Dendral after dendritic algorithm, and the next one called Mycin, which had a huge influence on this field. And really, expert systems became the core of this field for AI over the next couple of decades. In fact, around the same time, there were some work on neural networks as well. But there was a paper by Minsky and Papert, which actually said, that area can't really go too far. There are lots and lots of limitations. And so, expert systems is where really everybody went on and continued to focus on. Moving forward to, a few more decades, over to 2010s, really the last decade. During this time, there have been lots of changes. We've seen, there was an AI winter back in the 80s where people thought, okay, yeah, we've got some wins, but this isn't going anywhere. But there were a lot of technological improvements over this time that we'll start to see come together over the last decade. So let's briefly look at what kind of things we saw. One of the key pieces of technology that really came up during the last decade was this thing called deep learning. And this was really a retake of the neural networks, which, as I said, started way back when, but in fact, back in the 40s. And as I mentioned earlier, the whole, in the 60s or 1969 by Minsky and Papert, that paper sort of pushed these down for a while. In fact, it wasn't until the 80s that there were new ideas from John Hopfield and David Rumhart that allowed this to come up again and showed some interest. However, it still took a few more decades for it really come to the forefront, and it got rebranded as deep learning during this time. So let's take a look at how it's impacted us or what it's allowed for over the last few years. First is in the vision itself. If you look back to 2011, this particular goal, this is in a very, very narrow domain. It's not vision per se to solve for everything, but in a very narrow domain, we saw in 2011 that, on this test, in this case, ImageNet, humans got about 5% errors. And the best machines really were at 26% errors. So it's like making, 5 times as many errors as humans. It's really not useful for most things as is, right? You need humans in the loop for pretty much everything that you want to go. However, just move forward a few years, just a few years, we've gone from that 26% to 3%. And this is 2016, by the way. Over the last 4 years, we've made even more improvements in this area as well. Now, if you compare this to, how evolution happened and evolutionary biology, the time when animals first evolved eyes was a time for great change. We saw just all kinds of new organisms come up and lots of interesting things happen. And in some ways, we are sort of at this juncture and things have been moving so fast where with computer vision, we have this dramatic effect that what machines can do has just changed. And let me just give you a couple of examples of what's possible because of this. One key one that this enabled over the last few years as well is things like Google Photos. before this, and again, it's been a few years now, but before this, for those of you who remember, there were things like Picasa and others. You upload photos, and then you organize them, you label them yourself, all of that stuff. All that's just gone. Just how we interact with pictures is just, we take it for granted that our apps understand what's there in the picture and really can go from there. Now, we talked about vision. Some of the other areas, of course, are just hearing as well. If you think about us as humans or intelligence, we need to have the core perception things, and while vision is one, auditory perception is the other. And here, back in 2012, when things moved to deep learning from the older technologies, where we could now search for things or do things by just speaking to our microphone, that move really in 2012 was kind of like, as much as the research had improved over the last 20 years. So just one change in technology was equivalent to 20 years of research in that field itself. That's a really big deal, and that's really changed the game of how things work over the last few years. So one of the examples of what's enabled today, if you look at the phone, this example is from Android, where you can get live captioning right on your phone with whatever's going on. You turn off if you can't hear, let's say, it can take your video, take your audio, and really just caption it right there for you. And that just is life-changing for a lot of people who either can't hear or in noisy situations, etc. It just makes a big difference. Now, the third piece here is, hearing is great, but we want to understand what's going on. We want to understand what's spoken, and that's been one of the most limiting factors earlier. Now, just in the last 2-3 years, we've seen big strides in this. In fact, if we look at 2018, this particular data set was put together, and with some human performance measured on that data set. This data set is all about question answering. So this is for students, let's say, answering their questions, going through some paragraph or some story and trying to answer specific questions about that. In this case, as we see, 2018, we had this human performance at this level or whatever. And just last year, or just this year, in fact, we've gone way past that. This started a couple of years ago with this algorithm called BERT, and we've just seen consistent progress on that, where we're doing way better than the average human on many of these tasks. Of course, the way I like to think about it is, when I was a student, I wish I had this. It would have been great for me to pass all my tests or not have to work so hard. Hopefully it can help us with a lot of other things too, and we are seeing that not just in passing tests itself. And one example, of course, again, from a Google perspective, given that I've spent so much time there, is to think about search. How does it really change our experience with search? And if you take a look at this query, before we had this change, before we had this technology, you could see it was doing great matching all the keywords. So the first example that you see, it gets Brazil, it gets US, it gets visa. But as you can see, it's getting the wrong kind of visa, right? It's giving the US traveler visa for Brazil rather than the other way around. And in the after one, it's getting that right because it really understands that sentence. It's not just trying to use, what gets asked for more when I'm in the US or wherever am I, right? And so these kind of extra understanding of what's being spoken makes a big difference. And where it's really shown up for us is in this whole idea of, assistance. And, many of you probably have an Alexa at home or a Google Assistant, at least on your phones or even the device itself. They're both really allow us to speak to them. They are improving in understanding what we're saying. They're clearly not there. I have conversations with my Google Home all the time where I'm like, it really needs to get this piece. So there's still a way to go, but it's made a huge difference. And this is all just in the last decade in terms of, how things are. So we talked about so many things that have happened over the last decade. Now, one question often is, why is it happening now? Yes, we just said neural networks have been around since the 40s. So what's changed? Why is this so much more important now? And I think there are a number of things. So let's take a look at that. These folks, as you can see, these are from left to right, Jan LeCun, Jeffrey Hinton, and Yoshua Bengio. They are the Turing Award winners for 2018 for their work on deep learning. And between the three of them, they really laid the foundation. Them and, of course, a lot of other folks in this field, but they really laid the foundations for lots of improvements in these algorithms. That's led to this resurgence of neural networks, especially over the last decade. And so, algorithms is definitely one piece of the puzzle. Now, the second part, we saw that example about images. In fact, vision was one of the first areas to see this huge success. And one thing that we can attribute that to is this particular data set in ImageNet, which has, 1 million images for 1,000 different classes, each one having 1,000 images. And all the progress, the numbers that you saw were for this data set, for the accuracy on the data set. Having this clean data set allowed researchers to really publish things, really compare things and make improvements because they had a very clear benchmark. And so, number two, if I were to pick, was in this is data itself. And areas like ImageNet, for conversational stuff, Squad, all of these have led to improvements in research and how far we can go in these areas. Of course, sometimes we go overboard, and as you can see in this comic by XKCD, we've been trying to collect data to make progress in all kinds of things. And yes, self-driving cars is something we've been talking about for a long time. We aren't quite there, even though some folks would like you to believe that we'll have self-driving cars in just a few months. I think we still are a little far away. We can have them in very specific areas, and we will start to see some rollouts of those, but the most general offering is still a bit away. And data is only a part of that, but it does play a role here. Now, the third piece I would say is the computational power. This example is for TPU parts, something that Google created. It has 100+ petaflops in this one pod, or a supercomputer, really. And I was looking at the numbers, in fact, going back to the 80s. And, if I look at the fastest supercomputer in the 80s, this particular one that was created like 2 years ago is 50 million times faster, 50 million times more powerful than the one that we had back then. And what that allows us to do is just mind-blowing. It just changes the game on what's possible. And that's definitely been a key part of moving things forward. So, really adding to the other two, putting compute in there as well. So these are the three core pieces that have really come together, the algorithms, data, and compute, that have really made tons of progress and shown that progress over the last decade to enable this. Of course, to leverage all of these, it's not easy. You can't just program a supercomputer all the time or use all those algorithms. That's where tools like TensorFlow, which I'm humbled to be a part of, have really helped put all these together and made it possible for folks, whether it's researchers or folks building products, to combine those and do some exciting things. So let's take a brief look at the kind of products this has enabled. We talked about things on the phone earlier in terms of captioning. Here's another one on the phone where you can do live translation right there on the phone. You point it at something, you are in a foreign land. Again, we are probably not traveling too much right now, but when you do again, and I've done so in the past, you point your phone at some sign that you don't understand, it'll convert that, translate that right away. And in fact, it's well integrated into many of the apps that we see as well. Right there, it can convert from one language to another, so you can understand and you can leverage that to decide how to converse. Another example, this one a more vision one again, our cameras have really become, or our phones really have become cameras. And one of the most exciting things is, can we make it easier for you to take pictures? In this case, you just get the photo started and it'll take the best picture possible based on when you're all looking at the camera, when you're smiling, all the stuff, really getting the right pose there, getting the best one there. And of course, in the case of Google, a lot of the products, these are all the products that were announced last year from a hardware perspective. Each of them uses AI in a different way. For example, the assistant, of course, we've talked about. In terms of the phone, there are so many different apps, including the camera itself, that uses these, and many, many others, really. Another area that we've really changed and is likely to have a huge impact over the next few years is healthcare. That's something, of course, near and dear to us. It impacts how well we live, how we can improve that makes a huge difference. And it's not just for the folks who, in pushing the boundaries of the healthcare as it is today, but bringing access to a lot more people. So, for example, in this case, these are images of the back of your eye. And a common disease there is diabetic retinopathy, which can be found just by looking at these images. In fact, scientists are figuring out that they can tell a lot more from these images as well. And it turns out that we can automate some of this. We can actually, with the right kind of data and all of that, we can train models to do as well as doctors in this case. And going back to the accessibility piece, now this can provide access to way more people who just did not have access to the right kind of doctors. Something much closer in today's day and age, COVID, we are, of course, seeing all kinds of things, and anything we can help with from an AI perspective is great. And in this case, this company in India, and there are lots of other companies working on this as well, where it can look at X-ray images and validate what's the chances of this person being infected by COVID-19. So we talked about a lot of improvements. We've talked about so many different things that are happening in the AI, but what's about the enterprise, right? We are all at companies, we're trying to run businesses, we're trying to make new things. And how can AI help us? So is there something that's limiting us? Is it going to be possible? Let's take a brief look. So this is sort of, going back to the slide, what about our businesses? Is there anything here that we aren't quite getting, or do we really have all of those things? So let's take a quick look at each of these pieces and what's not available, or it is. Like in this case with TensorFlow, it was open sourced by Google. It's available to everybody. So, enterprises have it available as well. Algorithms, while they're complex and the research is often happening in academia or at big companies like Google, Facebook, and many others, most of these algorithms are made available to the public via open source along with the tools themselves. So that's really made it possible for other companies, all kinds of enterprises to leverage them as well. Compute is expensive and it's hard for everybody to have their own supercomputers. But the good thing is the public clouds have made a lot of this compute available to folks. And it's not just the CPUs that you have, but GPUs, TPUs, all of those are available in many of these clouds and something that we can take advantage of. Now, the last one here is data, which, of course, unlike, say, vision or text or natural language, we can't really take that same data or learnings from that same data across to the enterprise, because often each enterprise has its own data. And it's not like vision where, okay, if you learn to identify an apple remains an apple. Business data for each business is often very specific. And while there are some learnings across the domains, they're not as much as we would like. And so what's happening with the data? Let's take a look at that. I think one question is, do we have enough data? And I think we do. We definitely have lots and lots of data. In fact, this conference, of course, is all about how people can leverage this much more effectively with their data lakes. Once you have this data, you want to collect it, you want to put it in the right place, you want to sort it out, prepare it in the right form, and then leverage it in the different pieces. The good thing is there's been a lot of progress in that. There are lots and lots of tools that can help with that. There are lots of folks that have learned how to do this. And a lot of the other talks at the conference will go into details of how you can leverage this, how you can make a difference in leveraging your data that you have into some of the other things that you're trying to do. So I'm going to skip that myself, and let's take a look at some of the other things or how we can leverage this. Right. So even though sometimes it may feel like this, we've really made tons of progress in the data lake management and the tools around this. And like I said earlier, we have tons of talks around that we should go over. Now, going back to the slide again, is there something else we need to leverage AI? So we talked about all of the pieces, how we have them in the enterprise. And really the last one here is, people. Now, even with these tools like TensorFlow, it's still hard to use them. Not everyone can use these tools to put all these together. And if you think about data scientists, the people who've been using these tools, there're just not enough of them to build every single thing that we would like to do. So what's happening there? How can we make this better? There's been a lot of work going on to make these simpler. And these are examples of what we call AutoML. Many of our vendors are building AutoML techniques that really make it easier for more people to leverage these tools to build the models. But there's a lot more work really required for machine learning or AI to work on your data. It's not just about, okay, here's a clean data, let's just make machine learning work and everything will be fine. It's not magic that you just sprinkle on it. There's a lot of work that needs to be done. So how is this going to work? There are lots of ways this can work, but let's step back and see how is it working for some of the companies today. And going back to the example for Google, this again is many of the hardware products that launched a few years ago. What are these technology companies that have been able to leverage AI well? What are they doing? In this case, AI is really in their products. This is where they shine the most. For example, for Google, whether it's hardware products that we see here, or search, YouTube, Play Store, it's really all about how AI can make these products more useful. And products really for these technology companies are the core of what they do. That's the core where they shine. And really, that's what we should look for. So if you think about going back to the basics, and from a company's perspective, from a business perspective, or an entity's perspective, it's all about the core competency. Just like in the rest of business, we think about the core competencies, and that's what we focus on, and don't try to do every single thing. That's what it comes down to. Can we really leverage this to change or improve what's core to the business? Let's take a specific example. All right. So in this case, for MasterCard, which all of us are familiar with, most of us have credit cards from MasterCard. One of the key parts of the business that they're known for, and that both banks and all of us rely on them for, is fraud. Being able to manage fraud, detecting it early enough, making sure that people don't get defrauded of their money. And this is a very core to their business. This is something that they invest and spend a lot of effort around making it work well. Now, this is an area where AI can definitely help them, and they probably are already focusing on leveraging it to improve this. And we see this for companies that are really focusing on their core areas and building the right teams to help them trying to leverage AI in those core areas. I think they're making a fair bit of progress, and they continue to improve things. For a lot of the other things, it'll often come down to the same decisions that we do for other kind of things. If, for example, for MasterCard, it really needs to build and own the best fraud detection systems. It can't rely on somebody else building it for them. However, for many of the other areas, it can buy different kinds of pre-built solutions. Example, for marketing, it may be able to rely on tools from other vendors. And the same holds true for lots of other areas as well. It's really no different than how we think of software itself or how we build those things. Except in this case, I would say, in the traditional case, in, say, software, because there were so many software programs out there, you could really hire consultants and have them help and so on. In the case of machine learning, it gets harder because you really don't have that kind of expertise. The number of people who would know this well is still small. It's still in the hundreds of thousands, maybe, whereas you have tens of millions of developers today. And so in this case, we really have to focus on the core and try to find the right kind of products that can leverage AI and help us in those different areas. Of course, not all those products are here today. On the B2C side, as we looked at, on the consumer side, over the last few years, we've seen lots and lots of B2C products start to integrate AI and making them better. We saw that from the bigger companies like Google, Apple, Facebook, and so on. But we're also seeing from folks like, say, P&G. P&G launched this new set of diapers and other pieces to help folks really understand how well their kid is doing, is the kid asleep, all of those kind of things. And they're really integrating AI into making those better. Now, the next piece here really is, how can we bring this to B2B? I expect to see the same thing with B2B products through this decade over the next several years. And it's going to be a little like the move from on-prem to SaaS offerings. In fact, given that it's a lot easier to now build and integrate AI in the cloud, we'll see it showing up much, much quicker in SaaS products. We'll also see a lot more tech startups rebuilding some of the applications that we've seen traditional companies do and build those from the ground up to leverage AI in new and interesting ways. There's just so much more to do here that I expect to see over the next few years. And before I go, while thinking about AI, while it's tempting to expect it to solve all our problems, I really want to leave you with this last message. Artificial intelligence makes computers a lot more like us, and in more ways than we may like. Thank you. So, like I said earlier, there's probably a lot of other stuff at this conference that you want to look at, especially around the data, especially around the pieces on how you can leverage data and really process data so you can be ready to leverage AI and machine learning for your core areas. Thank you.